All right, welcome back to Mr. P Helps with Calculus. This is Unit 1, Day 5. We're going to be talking about properties of limits. All right, so as we get into it, so this is just a list of all the properties that you need to know. It looks very overwhelming, as I can tell from most students who see this for the very first time, but really most of these properties are actually very simple. So what it's saying is that if it's in limit notation and it says limit as x approaches some sort of number, doesn't really matter what c is, and you've got two functions that are being either added or subtracted by each other, then essentially all you have to do is just split it up into two limit notations. So you can take two functions that are put together using add or subtraction and split it up into either this limit plus this limit or this limit minus this limit, and that's it. And the reason why we're going to use these properties, because in the future you're going to use these properties to make the questions a bit easier, because you're always looking for that easiest way to solve a question. This one is our constant multiple property, which basically states that if you have some sort of number being multiplied by a function, then essentially you can take that number and you can pull it out and make it a coefficient. And it's going to be the exact same thing. So this and this are the exact same thing, or vice versa. You could change this into this if you really needed to, but that's not really what we're going to be useful today. Multiplication is the exact same thing as this up here. So if you have two functions multiplied by each other, then essentially you can just split that up into two limits notations and just multiply them by each other, just as you would see in here. Same thing with division. So division would just be split it up into the two limit notations, just put one over on top of the other. Now, there is obviously one caveat to that, which is the denominator obviously cannot be equal to 0, or then it wouldn't make any sense. All right, so exponentation, which basically says that if a function is raised to that power, then essentially that's like saying the entire thing is raised to that power. So you can put these brackets on the outside and say, well, hey, if the function is raised to this power, then really the entire limit is also raised to that power as well. Composition, which basically states that in this case, well, the limit is x approaches c of g of x equals a limit, then the composite function, so limit as x approaches c of f of g of x is equal to the limit as x approaches the limit of the inner function. So what you would do is you would find the limit of this inner function and then raise, whatever that answer might be. You could just plug that answer right there and do it again, basically. So the limit as x approaches whatever that answer was, whatever the limit of that inner function was, so you put that number right there, and then just do that to the outer functions. And there is a day that we're going to do this lesson. This lesson can actually get very tricky, but this is just the basics of manipulating the properties. All right, so let's say we have a question like this. So we have it's being added and subtracted. So essentially all I'm going to do with the addition and subtraction is just split this limit notation, which is right here. This is the function itself. Limit is x approaches 2 of 3x squared. That is the function. I know we've seen f of x and g of x and all these other letters, but now we know what the function is. We don't have to assign a name to it. And we're going to say that the limit is x approaches 2 of this function plus the limit is x approaches 2 of this function. And then we're just going to split it up into minus the limit as x approaches 2 of this part right here. Okay, so essentially we have just split up into three different parts. Now from here I can take that coefficient 3 times x squared and I can pull it out as a coefficient. Same thing with 4. 4 can be pulled out as a coefficient. Alright, so now essentially then it says if x squared, so I can basically make that 3 times, whoops, I'm going the wrong way. 3 times that entire function squared will be the exact same thing as well. Now, why would I do all this? Well, if I know what the limit as x approaches 2 is, then I should be able to just multiply it. So plug 2 in for x and I get 2. 2 squared is 4. 4 times 3 is 12. Now, I know what you're thinking. Why did I go through all that work? Well, the point of this was to practice the properties. Now let's double check to make sure that 12 is actually correct. If I go back to the original, because there's no indeterminate here, we don't have anything to worry about, I can just plug and chug. I can plug 2 in for x. 2 squared is 4. 4 times 3 is 12. Yeah, you're going to get the same answer, and that should not shock you because obviously these properties are all equal. Nothing has really changed. Now, on this next page of questions, now we're going to use the properties to our benefit, because now we're going to try to make this question have these pieces, because these pieces have answers to it. They're telling us as an answer key that the limit as x approaches 3 of f of x is equal to 8, and g of x is negative 2, and h of x is 0. So if we know these three pieces, all we have to do is manipulate the question in a way then it turns it into these pieces so that we can just plug 8 in for this answer, or -2 in for this answer. So first I would use my subtraction property, split it up into 2 parts. Then I've got the 2 and the 4, which can be constant multiples, be pulled out to the outside. And then essentially, look what we have here. So I have, oops, if I go back, I wasn't on pen. I have essentially these pieces, I guess I should put them in brackets here, that look exactly the same as the 3 pieces of information that they gave us. I guess this is sort of like a key up here. They're telling us what these functions have limits of at 3, when x is 3. So then I can just plug that 8, which is what the limit as x approaches 3 of f of x is, plug that 8 right here, and then I can just simplify, doing the rest of the math by hand. Same thing here. I'm going to use my properties. Now you can use the properties in typically any order you wish. In this case, I'm going to do the exponent first. So put 2 on the outside, pull that 2 to the outside. So that's your constant multiple rule. And then essentially you know what the limit as x approaches 3 of g of x is. It's -2. So just plug that in and plug and chug basically from that point. All right, this one over here, pretty complex. Sometimes, I'll be honest, I kind of do multiple steps at once, which is fine in this case, but I've shown my work using limit notation all the way until the point where I can substitute. So I changed this to this, so I pulled that 1/3 power out as a constant multiple, and that's all I did basically there. I left the bottom, basically what it was. I just used the division property. I used the division property over here as well, and I pulled out that constant multiple. And then I just plugged and chucked and basically found the answer. All right. Same kind of questions, same steps. This is just addition. This is honestly a little bit easier question than the one I just did. So it's the limit as x approaches a of f of x plus the limit as x approaches a of h of x. And I just plug the numbers in. They're giving us a new key. Plug those numbers in and solve. This one, constant multiple, I'm sorry, we have, not constant multiple, sorry, we have your exponent power, and then plugged. And same thing with this, 1/3 root, third root is 1/3 power. You should know power over index. Power of h of x is 1, 1/3 is 1/3. And then it becomes pretty easy. 2 to the 3rd power is 8, so that's what 1/3 power means. And same thing with this one, so this is 1 over f of x. Well, that's going to be flipped by changing it to the reciprocal to f of x to the negative first, and then raise that to the power, and use my properties. I just plug away and solve. Let me move myself over here. Just more examples, honestly. Pretty easy. Quotient one, another quotient one, another quotient one. So it seems like there's a lot of these, but remember, there was that rule. The denominator's not allowed to equal 0, so this does not have any limit, so it does not exist. This one, okay, couple of properties at the exact same time. I pulled out that constant multiple. I split this up using subtraction properties, and then I can plug it away. And the reason, like I said, that I can plug it away is because I've made the limit notation. I have made it, and I know I don't really use brackets as much as I probably should have. I'm making them look exactly like the key they gave us. So I can take this and say, well, hey, this is the exact same thing as 8. This is literally looks the exact same as this. That's the whole point of this. Before I can substitute, I want to make it, using my properties, make it look just like the key that they've given us originally. All right, more examples that you could see. I'm going to let you go through these examples yourself. They're very similar to the examples I have just done. I know I have these notes posted, but I think I've gone over pretty much examples of everything, and you can see my work is pretty neatly done. Let me know if there's any questions, of course, and thanks again for watching, and I hope you enjoyed the short video. Have a great day. See you on the next lesson.